Our first keynote speaker today is going to be Florian Kolb, who is the Chief Commercial Officer and General Manager Energy at Intertrust Technologies Corporation. So Intertrust here provides solution for data security for a wide range of applications. And Florian will be explaining why data is the new oil. Well, that's exciting. Florian, are you with us? Please join us on the virtual stage.
Absolutely.
Hi.
Thank you. Thank you. Hi. Good morning to Europe. It sounds like you guys had a blast over there in Europe the last days, huh?
Oh God, it hasn't been only Europe. I mean, we've been totally global here. 5 continents, 40 countries, totally overwhelmed. And where are you, by the way, tuning in from?
From Silicon Valley. So it's 1 a.m. in the morning here. Great time to be with you.
Yeah, this is actually the most productive hour, as I have heard, in the Silicon Valley.
That's true. And the internet connectivity is the best because during the day it's always a little bit weak. Yeah? In the heart of digital innovation, we have poor internet.
Yeah, well, obviously, US is not the American dream anymore, what it used to be, right? But California is, though. I'm a big fan myself.
I hope so. Yeah. We are coming back and we are still alive. Yeah? Innovation still keeps on going.
Yeah, let's see what's happening with the elections. So we are also really closely looking by that and looking forward to what's going to happen in November, right?
Yeah, don't talk about politics. Talk about energy. That's better.
Yes, we are here to talk about energy. Exactly. So I think, Florian, the floor is yours.
Yeah, thank you very much. I hope that you and your families are all safe and well. That's not a given these days. And also thanks to Lukas and to Rimas for having me. My name is Florian, and I'm the Chief Commercial Officer and General Manager Energy of Intertrust Technologies. And we are a Silicon Valley-based data technologies company with global operations and also a significant footprint in Europe. And we also have 2 teams in the Baltic. So we have a team in Riga and we have a team in Tallinn. And that's also one of the reasons why I'm here with you today. We also have a strong focus on the energy vertical. So a few words on my personal background. I worked 15 years in the European utility industry for RWE and Energy, which is now E.ON. And 6 years ago, I moved to Silicon Valley on behalf of RWE to develop a new and better data-driven products and services and identify major improvement opportunities for the utility business-based technologies. In 2016, I led a strategic investment of RWE into Intertrust, in addition with other new shareholders. Today, Intertrust is owned by E.ON, Origin Energy, Philips, Sony, Panasonic, and a big Silicon Valley, Japan-based venture fund. And we offer innovative data technologies and solutions to energy companies, and we help them to solve data interoperability challenges throughout the energy value chain. And I was appointed as their CCO beginning of this year. So the topic of my keynote, data is the new oil. The EnergyTechSummit guys choose this title. And I heard this a couple of times throughout the last years, but I thought that actually this is a little bit outdated. So what I did a Google search. And so I entered data is, so here are the results. You get, apparently, data is the new oil. You get something that says data is beautiful. And what I was surprised, data is the new bacon. So I clicked on data is the new oil. And that is actually a phrase that was coined in 2006. By a British mathematician, and it has 1.6 billion results on Google. So I was also intrigued by what's behind data as a bacon, and I clicked, and that has 188 million results. And I checked again, and it was mentioned the first time on June 26, 2013 by a tweet of Cloudera, that's a data technology company. And now, if you look, then there are blog posts and there are T-shirts and pictures on data is the new bacon. So my conclusion was energy data is the new bacon. And whether it's oil or bacon, I mean, who cares? I think what people are trying to say, and this is pretty obvious for many of you, that data today is a commodity, it's an essential resource, and it's pretty transformational, like oil in 1800, and maybe also bacon. So we should have a closer look at data in the value chain. Why is this so relevant today? So actually, there are three elements here. First of all, energy and the energy value chain is very complex. So energy data is generated across many, many different entities in energy, and it's generated from a very complex energy system and a huge number of assets. Secondly, energy is critical infrastructure. We all know that without electrical energy, we wouldn't be here today. So we have very high data security standards, and trust in data and how to deal with data is very key. And thirdly, there's simply a lot of data being produced from energy systems. So we have very, very large data sets. Electrical energy is a commodity that is a real-time business. So we have only limited possibilities to store the data. So this real-time element gives additional challenges. So data is really very, very important. So what are drivers of digital and data in energy? Apparently, you are probably familiar with the trends in the energy business. We have a very strong push to renewables and decarbonization and decentralization of the energy system, which creates more and more complexity. The old model where somebody would build a power plant, build a big pipe from the power plant to the end users doesn't really work anymore today. The second trend is deregulation and sector coupling. That is a very, very important aspect. So we have the Paris Agreement and the commitments to reduce emission levels and help fighting climate change. And if you look into the research that's available, then there is a very strong belief that this is only possible if we decarbonize not only the electrical energy system and the sector, but also transportation as well as heating and cooling. And we need to combine these sectors together in an intelligent way to ensure that our emission levels will go down. Apparently, I'm living in a country where not everybody has this belief, but in general, that's the absolute consensus globally. And then the third mega trend is electrification of transportation. And that is really the most present big challenge that we have to tackle. And how we can do that with data, I will give you a short example at the end of my presentation. So the orchestration of the new energy system requires secure and trusted data interoperability. So that is within companies, but also between companies. We have these renewable energy resources that are nonlinear, that require precise prediction with regard to their output. We have a lot of IoT-enabled devices these days, which create a lot of additional data and additional insights, but also security challenges, which require very careful data management handling. Everything is distributed today. A lot of distributed energy resources, matching supply and demand becomes a challenge. And of course, data governance and regulatory requirements around data are very important. So in a nutshell, managing the flow of data from a distributed energy system is as important as managing the flow of electrons within the system. So what are the challenges and the risks? Secure and trusted data flows within and also between organizations is a very complex task. So here are a couple of the issues. We have technical issues. which simply result from the fact that data of the Energy Tech Summit is AWS, which provides physical infrastructure that companies use. But there are many, many other providers for this kind of infrastructure. And especially in the utility industry, there are also a lot of companies which still use proprietary data centers. So that's one challenge. Another challenge are strategic issues. So if we have data and if we see data as an asset and we start doing new things with the data, there can always be a risk associated with that. And decision makers have to weigh what are the risks and what are the rewards that we can get when we do more with the data. There are also business case questions. So is it really worth the effort to do more things with existing data or to acquire new data assets? And what is the potential exposure that we face as a company if we share or if we work together with external parties on data problems? We have legal issues, so we have very restrictive data rights legislation such as GDPR, or we have industry-specific regulations. So, for example, what are we allowed to do and what are we not allowed to do with data that comes from smart meters, which has also certain privacy aspects attached to it. And then, and that's a really important one, we have cultural issues. People tend to be more on the data hoarding side, so trying to acquire more data for themselves versus collaboration. And within companies, we also have personal issues, career issues versus business issues. So it's a very, very complex setting that we are facing. Now, how do we solve these restricting issues? To manage cloud-based or on-prem datasets within or between enterprises, we need to use data technologies that enable trusted data exchange between businesses and partners. And organizations with large and sensitive datasets must govern, secure, and distribute data across any cloud service or infrastructure, because otherwise the value and the opportunity cannot be captured. So at the end, the goal is analytics and more analytics. So machine learning, AI, people use these terms all the time, but without access to data and availability to data, that's not possible. So we need to have efficient and secure data management workflows that take us there. So we take the data from the source, whatever nature the source is, we have to put it into an environment where data operations can be executed, workflows can be executed, and workloads can be executed. Secure analysis can take place, and then the results are distributed to the end users in different verticals like energy, transportation, insurance, or IoT. So what needs to be done? There are three things. We need to connect. We need to create data sets from existing business solutions and data sets. Every company has a set of applications, has an existing architecture, and we need to be able to connect to that. We need to securely blend and process data from multiple sources. We need to provide unified access to all downstream stakeholders that are required in the data value chain. The second aspect, we need control. We need to limit the access to the data and the information only to the required stakeholders. We need to enforce very granular and policy-based data access for users and also for applications, so in machine-to-machine communication. And we need to provide secure execution environments that protect the raw data and also the IP that's within analytics. The third element is we need to comply and we need compliance. We need to monitor and record all data access that is requested and the responses. We need to allow security audits to review events, and we need to demonstrate compliance with regulatory requirements. So how is this done? There are three elements in the data world that need to be present. First of all, data governance. So all data requests are subject to privileges granted by administrators. Users get data they need, nothing more. And If you go into big data and multi-cloud and multi-data source environments, this becomes very, very complicated and very, very complex very quickly. The second element is data virtualization. So you can't sometimes not move around the data because the data is too big, the data is too private, or it's technically not possible. So we need to find ways to access the data and create virtual data sets via different technology approaches. Execution environments. So data platforms today have to act as trusted third parties, allowing data owners and service providers, such as analytics providers, to collaborate without exposing the data or the IP to the parties that interact. So what's needed is to create a system that ensures the control of data and that the control of the data is maintained, so that between companies, data exchange can happen in a secure and efficient way, or also within organizations. So what you see here is company A and B and C and D can also be within an entity or an organization or a big corporate. And that is very important, that all these elements are present. So when you do that, then you can declare victory and the mission is accomplished. So if you use these technology approaches, then the required functionalities that you need are there. So you can maintain control of your data at all times, eliminating the risk. You can govern data where it resides without duplication on-prem or in the cloud. You can enforce consent management and audit data access to ensure compliance with legislation and also industry regulations, such as the smart meter example that I mentioned. And you can provide secure execution environments where machine learning or AI algorithm can do their work on data without compromising and without exposing the data too much or the intellectual property of your service provider and partner. And actually, that's a very, very important capability also to work with startups. So one of the very common problems are that startup has developed certain algorithms that are assumed to create significant benefits, but to prove that you need data and you need access to the data. And the question is how to bridge that. I think in Lithuania, there is also a very good government initiative that tries to facilitate that. But at the end of the day, the utilities have to provide these mechanisms to also enhance innovation in this space. And I can tell you that also in the United States, like very prominent research institutions like Stanford University and others are really struggling getting access to the data to do the innovation and the research work they need to do. And last but not least, you can provide end-to-end data security and identity, which is very important. So from a device level to the data platform level, data is safe, data is clear, and it's very difficult for hostile people to corrupt the system. So this was a little bit the theory. Now, how does this translate into practice? So we, together with our shareholders from the energy vertical, have deployed such new and powerful data platform plays across the energy value chain. And so we've done that in renewables. So for applications for offshore wind farms that produce a lot of data. So an average turbine in a wind farm and the associated equipment around that generate around 1 or 2 petabytes of data every year. So if you have a farm with 100 or 200 turbines, that's a massive amount of data that needs to be crunched and that needs to be worked on. And we are also expanding this into onshore wind and also solar. The second area, and that's also where I brought an example for you, is in distribution grids. So we have full-scale data from distribution grids, including hyperlocal data from smart meter that can be ingested in the infrastructures that I explained to you. Also on the retail side, there are more and more connected IoT devices, such as smart meters, but also smart home devices that people start to use. And these devices generate a lot of very sensitive data. And the question is, what can we do with the data to create additional benefits and insights for customers? Another very, very active area is smart cities. So cities are a very important stakeholder in all infrastructure plays. And there is a need for data aggregation and sharing also data for city planning purposes. And the last point here, that's a new activity, ESG. So in environmental management, due to what's going on in the world, there are new reporting and also new management requirements. And this whole ESG area is faced by more traditional approaches, how to deal with data and data operations. So that's also where data sharing and data interoperability becomes more and more important. So let's dive into a short case study that I've brought to you that should explain that, what I told you is also something that is relevant and from our perspective also provides a lot of opportunities for startups and also for investors to look at. So one of the key challenges at the moment for the utility industry is electric vehicle infrastructure planning. So it's very clear that if there is an explosion of electric vehicles, this will impact grid capacities. And the medium and low voltage grids actually are the future fueling stations for electric cars. That's not a surprise for utilities. Sometimes it feels a little bit like a surprise for car companies, for regulators, and for governments. And what the research shows is that high levels of EV penetration will require a coordinated charging and transmission and distribution grids to ensure reliability and also efficiency. So there's a ton of research that Stanford University has done, which leads to the conclusion that if we have electric car penetration rates of 20% or more, we get issues around grid management. And there are many, many different solutions out there that are being developed. So shifting loads via incentives and tariffs is something that's very popular in the US. So to let the market and price mechanisms decide how to optimize supply and demand. There are models in Europe and Germany, for example, where curtailment from grid operators is being discussed. Vehicle-to-grid communication is an opportunity, or bigger batteries in cars. So one of the key questions and problems that actually utilities are facing is to assess where grid capacity will be a bottleneck in the future and under which EV growth scenarios. So this is something which is of interest to many, many stakeholders. So we have the utility, which needs to decide where to allocate future grid investments. We have the regulator who needs to achieve the lowest cost possible for an optimized energy system. We have EV customers who simply want to charge their car where they want and as quick as possible. We have the EV automakers who build very expensive factories these days to produce electric cars and who have to overcome range anxiety, issues with customers, and who need to educate customers on the point of sale. We have cities and municipalities that need to plan infrastructure and that need to understand what's the infrastructure impact of electric mobility and also how they can get greener and how they can improve their CO2 footprint as a city. And we have environmental agencies that want a faster EV adoption. So this is a multi-party approach here, and we need to blend and analyze a lot of data from a lot of different data sources to answer all these questions that I just sketched out. So from the utility. We need grid data from transformers, substations, down to the household level. We need the status of distributed energy resources from households and businesses, so rooftop solar, heat pumps, residential storage. What are the opportunities for flexibility in the grid? And we have other infrastructure data such as street, houses, garages for EV charging, gas, water, telecom, everything that is around us. A data layer that's relevant is socio-demographic data. So, for example, the electric vehicle mindedness of certain communities, the consumption behavior, the purchasing power to predict what will happen in the future. We have car data, which is very important from electric vehicles and plug-in hybrids. So what is their location? What is their battery status? What is their charging status? What are they doing? What are they not doing? This is all relevant to answer some of the questions. And we have planning data. So what are already planned changes to the existing infrastructure for grids, electricity grids, gas grids, streets, and so on. So many, many different data sets that have to talk to each other. So these deliver applications if they are enabled for capacity planning, scenario analysis, investment planning, hotspots and priority analysis, regulatory management, and also sales for electric cars or decentral energy resources. So based on the technologies and the concepts that I've introduced to you, we have built together with Innogy, which is now E.ON, a solution which is an automated grid information calculator that supports multiple data requests and has a very tight governance wrapped around it that helps people reduce planning time and costs, gives people secure insights into the data, gives rights management access for multiple parties, a very user-friendly interface, and has immediate cost impact, grid impact via advanced scenario and grid calculation analysis. So these are all the elements that I explained to you before. We have productized them here in an application that solves some of the key challenges that I have mentioned. So what you can do with that, just to give you a bit of a visual impression, you can add new EV chargers with existing infrastructure very, very easily with all the data available on one platform that comes from multiple sources and from multiple different entities. And you can actually do live calculations, violations, and alternative scenarios for planning EV infrastructure just with a click. And the reason why I'm showing you this is because this shows actually how to release the power that is in the data that we are all talking about all the time. So I think this is a very good example for what's possible. And we think that this is really a demonstration that data can be either the new oil, if you like, or the new bacon. So I'm at the end of my presentation. Thank you very much for watching and listening. And if you would like to know more, then this is a time for you maybe to take a screenshot. So we have summarized a lot of this content and more on our energy-related website. Thank you very much and enjoy the rest of your day and have a great end of the conference. Thank you so much.
Thank you so much, Florian, for joining us and sharing your story. Really appreciate it.